Hello and welcome to this live webinar hosted by UCL Mechanical Engineering. It's brilliant that there are so many of you joining us, not just from our department, but from far away, because we've got a very exciting story to tell today. We've obviously all just lived through an exciting and dramatic period. COVID came along at the start of the year, it shut everything down. We learned who our neighbours were. We learned about supply chains for food we'd never even thought about. We learned about isolation and community. And we learned that there is a fifth horseman of the apocalypse, and that'll be the one that's just run off with all the toilet paper. But we also learned that humans are capable of amazingly collaborative achievements, that humans work best when they work together. And that when there's a common aim and a dire need, brilliant things can happen. And so we're here today to talk about one particular project, and I'm very proud that it happened in the department I work in, University College London's Department of Mechanical Engineering. And this event was titled, it had miracle in the title, and I'm not really on board with that, I have to admit, because it wasn't a miracle. It was the best of what humans can do. It's not miraculous, it just takes hard work and good people. So everyone who's joining us, we will be taking questions from you. So if you think of questions along the way, then please do put them in the YouTube chat, which is just below the screen you're presumably watching right now. And we will answer as many as we can as we go along. I do have to say we have a lot to cover, so it might not be all of them. So make your questions really good because we'll pick those ones. So I'm going to introduce our panel. They each give you a little wave to tell you who they are. And it's important to say that although these were the key players, some of the key players, this is just the tip of the iceberg of the team that made all of this work. So first of all, we have Professor Rebecca Shipley, who is the director of the UCL Institute of Healthcare Engineering and a professor of healthcare engineering at UCL. We have Professor Tim Baker, who's a professorial teaching fellow at UCL Mechanical Engineering. We have Ben Hodgkinson, who's the head of engineering at Mercedes-AMG High Performance Powertrains. These people with these immensely long and exciting job descriptions. We have Tom Peach, who is a teaching fellow at UCL Mechanical Engineering. And we have Ismail Ahmad, who is a UCL alumnus and also a PhD candidate in our department. Now, we're going to tell the story of the Ventura project through a series of objects that came up along the way, and we're going to ask our panelists to talk around those objects to really share the flavour of what this was all like. So we're going to start with our first object, and Tom Peach has the first object. Tom, what have you got to show us?
So this, I hope everyone can see it nice and close there. This is a pan au chocolat, and there was a strong arc of pastry running through this project. You may not seem it at the beginning, but really the project for us began in a local cafe near our department about 2 days before lockdown, where we met for lunch, and what we were waiting for was someone to bring a carrier bag full of old medical equipment to us so we could have a look at how these devices used to work. So like some old mechanical devices that we would then use as the basis for this entire project, really. But also there was pastry, because it was my job every single day to order breakfast for the team. So we lived in sort of together for about 8 weeks in one of our departmental workshops. We spent about 14 hours a day together, some of us. So it was a bit like a weird sitcom, 3 meals a day. And yeah, it was my job every morning to order breakfast. And we would always get the family bundle of pastries, which was rather nice, because we were this odd mix of people acting as a family while everyone else was locked down, and we were working away on this project, but eating a lot of pastry along the way.
Engineering is fueled by pastry. So Becky, tell us, we've painted the picture of all these engineers in one place. What were you doing? What was the game here?
Really, the game was that we all came together and we wanted to do something to try and contribute to the need for more ventilation devices in our National Health Service in March. So I don't know if everyone remembers, but it was mid-March, and essentially COVID was coming. The wave had, already was going through China, had gone through Italy, and it was clear we were progressing along our first wave in the UK. Boris Johnson announced his ventilator challenge, which was to bring everyone together in the UK to make more mechanical ventilators for our National Health Service. We went a bit off tangent, basically. So we met up with Mervyn Singer, who basically runs the critical care unit at University College Hospital, which is our kind of partner teaching hospital. and chatted to him about what he thought they really needed. And now he'd been talking to China and Italy, and he thought that we needed CPAPs, which are non-invasive devices to deliver oxygen to patients, as well as mechanical ventilators. The advantage of CPAPs is that they are potentially simpler devices, and so we thought we had a chance of actually manufacturing them and, well, designing first, getting regulatory approval and manufacturing them within a timescale to actually help for the first surge, which was due to peak in London around the Easter weekend. Now, you know, we formed our team really quickly. Tim and I are basically in the same department. We're in the mechanical engineering department. I already knew Mervyn. Tim had this long-standing relationship with Mercedes HPP. So we thought very quickly that we had the potential to bring together this combination of experts in engineering design, mechanical engineering, healthcare regulation and manufacture, which were all of the pieces of the puzzle that we thought we'd need to progress. And essentially we did. In long story short, we got an order from the Department of Health and Social Care, made 10,000 of these devices for the NHS, and now they've gone out to over 125 hospitals so far and continue to do so.
Well, let's just make one thing clear right at the start here. So we're going to be hearing a lot about CPAP. So just tell us what that stands for and what exactly that means physically. Absolutely.
So a CPAP is a continuous positive airways pressure device. And essentially, it's a device that takes oxygen, pressurized oxygen from a hospital plug point, if you like, in a ward, and it delivers it to a patient via a breathing mask. And the idea is that you inhale this pressurized oxygen, which essentially splints open your lung bases and allows you to get more air into the lungs than you would do if you were just breathing or had normal face mask oxygen. And essentially, patients who present at hospital who are suffering with COVID need respiratory support, and they need you to get more oxygen into their lungs. So it's a way of doing that which keeps the patient awake and talking, so without the need for essentially mechanically ventilating them, which is when the patient has to be sedated and you put a tube down basically into the patient's lungs and breathe for them.
Brilliant. Okay, well, let's move on to our second object, which Tim has, and we're going to get into the design of what it really takes to make one of these things, to make it work, what the challenges were. So Tim, you've got a sensor to show us.
Sure. So obviously the CPAP, the device itself, got the headlines, but as soon as we got the design and the manufacture for that underway, I was talking to medical suppliers and looking at getting all the pipes and masks and filters that we needed to go with everything else. And I discovered that there was a huge shortage of other components. So it wasn't just the breathing devices. So we found that in particular, oxygen sensors were in huge demand. And obviously each of these devices needs an oxygen sensor to go with it. So coming from an automotive motorsport background, I thought maybe there's something we could do with this little object here. So this is a lambda sensor, and if you drive a car that has an engine, it will have one of these in the exhaust tailpipe. And what that does, it measures the oxygen concentration and controls the engine strategy to make sure that emissions and engine output are correct. So I thought that possibly we could use a device like that and reconfigure it and use it as a medical device. And so working with some of our other contacts in the motorsport industry who have a specialize in electronics, we put a device together, and this is what it became. So inside that little box, there is one of those sensors which you'd normally find in the tailpipe for an exhaust, and as well as making 10,000 CPAP devices, we also made 10,000 oxygen analyzers to go with the kit that we were producing.
Tell me a little bit about the design elements that were necessary for this project. So we've talked about a CPAP device and we've talked about the oxygen sensor, but where were the tricky bits? Where were the sort of pinch points in getting all this done?
Time was the huge issue, really. We come from a background where we know how to make quality bits of precision engineering. we've never done it in a scale of delivering thousands in such a short space of time. So it really became an issue with managing the supply chain to be able to do all of that. So we got on top of sort of the materials we needed. We quickly reverse engineered. So what we did, we literally cut the device that we've been given in half and started measuring that and creating the manufacturing drawings. So that is kind of like our field. We were good at that. But then we also realized that it was the whole supply chain. This is the big issue, that everybody was hanging on to components. So we had to start working out how to make things for ourselves. And there are quite a few other parts apart from the CPAP that we manufactured from scratch to go together with the kit that we put into hospitals.
And just to be clear here, that in order to get this, one of the things that made this work very quickly was that you had an existing device and you wanted to make more of them. That was critical, wasn't it?
Right, because it had to go through regulation. So what we were able to do was prove equivalence. So we could say, here was the one that already existed. It hadn't been used for quite a number of years. One of the things we've been asked to do was to ignore all of the touch screens and bells and whistles and clever bits of electronics. We need something that's very simple, physical, mechanical, easy to train people with. So that's why we went for something that was a few years old, and then we could quickly turn that around and get that into production.
So Ben, let's come to you. Now, it may not be an obvious jump from healthcare engineering to Formula One. How did all of this land on your desk, and what was your role in it?
Well, I've had a long working relationship with Tim, and I also visit the university probably about once a month, so I've got a fairly long relationship there as well, and I was actually working from home that day, and when Tim called me up and told me about this challenge that he wanted some help with what I thought was a respirator at the time, so I quickly double checked with my boss Andy Cowd just to check that I could help out, and he was all for it and said, yeah, go and get involved, and whatever you need from Mercedes, just ask. So I drove down to London. I met in the famous cafe that's already been discussed, and saw the CPAP for the first time. I have to say that drive was I was quite apprehensive, imagining that I was having to come up with some large mechanical lung with hundreds of working parts, and I was pretty excited to see a fairly simple device that was just a block of plastic with some pipes and valves in it. I thought, oh, we can do that. That's completely up our street, sort of thing that's machined from solid that we can produce in a small number of hours. So we set apart trying to take the thing apart, work out how it works. Classic engineer stuff that I've been doing since a boy, really. Take things apart and see if you can put them back together and work out how they work and make them better while you're doing it.
And just give us a sense of what Mercedes offered in terms of practicality here, because that was where the manufacturing was done, right?
Yeah, that's right. Well, I guess first it was the design. So once I worked out what was necessary, I called some friends and colleagues from Mercedes and got them to come down to London and draw up all the bits. And as we was drawing parts, I was sending images and drawings back to the factory. We wanted to get the machines turning within a small number of hours of starting, so that's what we achieved, and we ran our first actual housing off just a few hours after we'd started, just to check that that we could machine the shapes that we wanted. So Mercedes offered the design. We also provided a lot of analysis support. So we did some CFD to try and help make the thing significantly better than the original. And then all of the manufacturing and testing. So provided the entire CPAP, really.
Brilliant. So we're going to move on to our next object now, which Ismail has, and it is the device itself, but it's the label that you want to show us, Ismail. Go and show that to the camera.
Yep. So my main contribution to this project was actually the graphics, such as this label here on the CPAP and, for example, the user manual. And this sort of mainly came about as I was actually the only person in the group that had done a bit of graphics design in the past. So I had all the softwares downloaded and ready to go. And this has actually meant I have now the much acclaimed title of graphics boy within the group.
You're not making that up.
I think Ben coined the term originally, so he can take credit for that. But no, graphics, I think it might stick for a few years to come.
But you know, the graphics are more than just the pretty bit that makes it look nice, right? They have a really important function. So just talk a little bit about the design of the graphics and the function that was required of them.
So, I mean, all the conversations around the graphics were really, how do we get this, get the message across to the doctors and the nurses in the clearest way possible, in the smallest number of steps, so that they have no problem in getting the device up and running as quickly as possible. So, you know, for example, I've got the user manual here, and the original one was many, many pages. You had to, you know, flip pages, scroll through it, try and get an understanding. But we sort of condensed the entire process into 8 main steps here. And then, for example, very, very simple user diagram that anybody can look at and put together. So absolutely, it's not just to make the device look pretty, it's to really get the idea across of how to use it in the shortest amount of time possible.
Becky, we've got this picture here where you're all living on pastries. You've got all these people, you've got Mercedes, and you know, you've got all these experts doing this stuff, and you've got an aim. Did you ever worry that you might fail? Did you ever worry that perhaps this just wasn't going to happen?
Yeah, it's a really good question. So it became really clear to me very quickly that we had the engineering, design, and manufacture piece under wraps. So, and that's not to undermine that piece. I mean, that was an absolutely phenomenal achievement. And for any students that have just joined Mech-Eng, you've joined just the most phenomenal mechanical engineering department. But there was this kind of backdrop of everything else that was going on in the UK in terms of kind of politics and healthcare at the time. So, you know, to give you a kind of piece of how well the engineers did, we went from a standing start, so first meeting on the 17th of March, to within 100 hours, Ben and Andy had driven back from Mercedes with the first prototypes, physical prototypes, and we were testing them in the hospital. That's how quickly the team moved, which was phenomenal. But the kind of background context here was that at this time, CPAPs weren't a priority within the UK. So the national priority that had been set by the UK government was for mechanical ventilators via the Ventilator Challenge. And now we'd defined this separate need, which was really based on our, you know, our clinical colleagues' experience from talking to this massive international network. And you know, the evidence was really compelling. So Italy and China were finding that CPAPs were stopping around 50 to 60% of patients from progressing to needing mechanical ventilation. So there was a real need there. But because we weren't part of the formal Ventilator Challenge, we needed to get this onto the agenda, and that had multiple components. So first of all was within the NHS.
We'll tell you what, we might come back to some of those in a minute. I want to go back, take a step back a little bit to what all the bits that needed to go with this. So our next object, Tom has, and it's well, it's quite a large thing, Tom.
It's quite, yeah. I'll loom into view with it. Yeah. It's quite hard to get your head around because it's clear plastic. But this is a CPAP hood. I'll put it back down there. So as Tim mentioned, really, once we worked out how to make the CPAP device, it was all the other parts of the patient circuit that became the problem, because once you had 10,000 of one thing, you didn't have 10,000 of everything else, it turns out. So we had to go out, and Tim's mentioned the lambda sensor. This was another component. So in some of the early devices, you'd put a mask on the patient, but these patients would be sitting in hospital for a week, 10 days, 2 weeks sometimes, and that mask became really uncomfortable and it lost the seal, and pressure is really important in this treatment. So those hoods, something like that, goes over the head and seals around the neck. It's much more comfortable and provides the therapy. The problem is they were only made by 3 sort of cottage industry companies, and all 3 of them were in northern Italy, within about 20 miles of each other. So it turns out northern Italy makes those, but no one else does. And as everyone will probably remember, northern Italy was not in a particularly good way during the COVID crisis. So no hoods were leaving northern Italy. They were what we needed. So that was another device that we ended up developing, feeling a little cocky once we'd made one device and taken it through the regulator. We thought, well, we're on a streak now. Let's move on to making hoods. So we designed and manufactured that with a company called Avon Protection, and then developed that in-house, took it to the hospital to test it, and did some of the initial testing on ourselves, actually.
And I think there's some pictures of you that we might have very bravely testing this on yourself. But so Tim, there's a question that comes from all of this, which is that this is all brilliant. There's all these engineers and people doing stuff. That's great. But out there in the world, there are already massive manufacturers of medical devices. There are people whose job it is to do this all the time. Why weren't they why could you do this, and why weren't they doing this already?
Before it all started, do you remember that Boris Johnson was saying they were going to kick off the ventilator challenge and they were going to get the automotive industry to start manufacturing? And I kind of thought that they make amazing, brilliant products in huge quantities, but that has a long development process to go with it. So I was sitting there thinking, if I was doing this, what I would do, not realizing that within 48 hours I would be actually doing. And I kind of thought, motorsport is they can do the precision engineering very quickly and hit deadlines, and that's the direction that we should go in. So I figured that was perhaps the direction to go. Also, the logistics. People talk about just-in-time logistics. So mass production, that is literally you turn around, the parts are there to put into the assembly on the production line. So we also tapped into that to create our own logistics team, and producing 10,000 of these things. And we've got our beautiful engineering centre in King's Cross, MechSpace, but just the cardboard boxes for the first run of components was we were running out of space before we'd started doing anything. So we set up a logistics arm to go with it so that we could deliver directly into the hospitals within the NHS. Yeah, there you go. There's one of the pictures that just shows you. I mean, if you see 10,000 of those boxes stacked up, that's a lot of bits.
So did you ever get anyone from the existing engineering companies coming along and saying, oh, well, we could do this for you, why don't you just let us do this? What was that relationship like?
Sure. So it all started, my phone bill was astronomical, and I was just ringing people. So I phoned one of the huge medical suppliers called Intersurgical. They didn't know who I was, and I phoned up and said I was from UCL. We're doing something for the ventilator challenge, and they were kind of like, well, isn't everybody? And they were being snowed under. This is one of the things, it wasn't very well coordinated because it was a free-for-all. Everybody was trying to get hold of the parts and short runs of components to be doing all of their testing. But somehow we managed to build the credibility, and it's perhaps one of the things I teach is your first impression has got to be so strong. So we made sure that anything that we handed over was really high quality, and we were able to convince people like Intersurgical to start working with us. So they actually, we started getting components quite literally out of the side door, outside the system, so that we could be doing our testing in hospital, and then gradually we were able to ramp up to the sort of quantities that we had to deliver.
Brilliant. Well, let's come back to Becky, and your second object, Becky, is a letter which picks up the story from where you left off before. So tell us about the letter.
Yeah, so this is it's one of the many letters that we were writing at this stage, and this was all part of trying to get CPAP on the agenda. So the first thing that happened was that CPAP joined the NHS care pathway for treating COVID patients at the end of March, which was a big step forward for us because it meant that CPAP was now on the national agenda. But concurrently with that, we were applying for regulatory approval. We were in daily communication with the MHRA, who were really phenomenal collaborators. There's a chap there called Neil Maguire who is on my friends and family's list on my phone. We've had many chats to him. We were progressing through the medical regulatory process, and then we got our first regulatory approval. But we also then needed to take that to the Department of Health and Social Care and get an order from them. So not only were we now getting to the point where we were having to invest a lot of money ourselves in the development and delivery process, but there was a whole supply chain network that needed to be guaranteed. So this is a letter that we wrote on the 28th of March it went to Boris Johnson, that was basically setting out the case for CPAP and the fact that we could deliver. And looking back, so this was a letter that I remember getting a phone call from David Lomas on. It was a Saturday morning, and he said, Lord Karkar, who is chair of UCL Partners, says he'll forward this letter from us to Boris Johnson, and we need it in the next 2 hours. So Merv and I basically went into a hole on a Saturday and wrote this letter. It starts with, we hope you're feeling better and make a rapid recovery, because at that time Boris Johnson had just been in the press that he'd got COVID. But essentially we set out the whole case, and we really kind of put all of our contacts and reputations on the line, in the sense of we were really outside of the kind of the mainstream direction of travel at the time. And you know, I think ultimately we were borne out. You know, these devices have gone out into the NHS. They've, you know, been uptaken internationally as well. They're currently being used in over 125 hospitals in the NHS. And you know, the evidence is really strong. So if you look back over the first surge of, you know, the first wave of COVID in the UK, mortality rates in intensive care patients fell by about 21% during that time. And that coincided with a 26% reduction in use of mechanical ventilators and increase in use of CPAP. So there was a real change in the approach. And, you know, fortunately, because of the composition of the team and the dedication of the team, we were able to deliver the devices that, you know, that helped to enable that.
And did you ever meet the sort of, I don't know, a prejudice that this is, that we all think universities should do this sort of thing, right? Everyone, if you ask them, will say, of course, universities should do this, but there are obstacles to making it work in practice. What are the lessons about how universities can help society in these ways that come from all of this?
Yeah, I think, you know, in normal times, there's huge amounts of bureaucracy, not only in universities, but, you know, through the medical regulators, etc. I think we were in a really unique position that because of the urgency of the need, we could completely cut through all of that red tape. So the regulator was working in a completely different way. We got regulatory approvals for Mark 1 of the device in 10 days from a standing start. But within the university, I mean, the Faculty of Engineering Sciences were just phenomenal in supporting us. I remember ringing the Sarah Collins, who's the Director of Operations for the faculty, on a Friday, and this was the first Friday and we were going into the weekend, and we knew that we'd need to be able to spend about 200k by the Monday. And anyone who knows university processes knows that, you know, that doesn't get signed off easily. But I remember ringing her, it was probably about 3:30 on the Friday, and saying, this is what we need. And she said, okay. She put the phone down, she rang me back about 10 minutes later, and it was enabled. So, you know, we had phenomenal support, and it really showed what you can do with the right team. So, you know, the composition of industry, academia and healthcare, but with, you know, such a permissive and supportive environment around you as well.
Brilliant. So Ben, let's come back to you. What was life like for you during this time? I guess there's a lot of, you described the design bit at the start, there's meetings and prototypes. What was your day-to-day life like after that? Were you helping make these devices? What was it like from the Mercedes HPP point of view?
Well, I guess the initial part was the drawing, getting all the drawings done down in London. I remember that being an incredibly intense period. I think it's in 3 days we had a total of 4 hours sleep. So we were working late into the night, and then bringing the sort of bits back, sort of down with Andy, and to do all the testing. I remember that distinctly. I remember trying to problem solve some high pressure on the out breath, and sort of fashioning a thermometer out of a piece of tubing and some filled with some water, just to see if we could have a makeshift measure the pressure on
which is straight out of an undergraduate textbook, right? If you want to make a very simple thermometer, that's how you do it.
Yeah, but unfortunately, sort of after we delivered another 10 CPAPs, then I actually got sick myself. So I spent the next 2 weeks recovering from what I assume was COVID. So I actually missed a lot of the intense production, unfortunately.
Well, I'm glad I hope you're better now. I'm glad you're better. You sound okay. Well, let's come to our next object, and this is Tim. Tim is wearing this one. Tim, tell us what this is. This is what university lectures are all about, everybody. Come on. Right, tell us what that is. We can just see the word at the bottom, which is the important one.
That's the t-shirt. This is what happens if you leave engineers to look after themselves. I came into work on I think it was on the Tuesday or the Wednesday. Told my wife that I didn't know what time I'd be home, meaning that day, and I didn't go home for 4 weeks. So we gathered everybody together, and everyone just hopped in cars, jumped on trains, came into London, and we literally didn't bring anything with us. We got totally engrossed in the engineering. We worked all through the night, and then we suddenly realised actually we hadn't got anything to go for the next day. So we sent one of the team away to King's Cross, St Pancras, because there were still a few shops open there. It was a very strange time. It really was. Central London was deserted, and they had a choice of, I think, of sort of like suit dress shirts, or pajamas, or these tops. So we came back. They came back with these tops. That picture that you saw, that was us the following day. We were in the Royal National Hotel, which some of our students will know because we've actually done some teaching there. Royal National Hotel was pretty much deserted. It's like 2,000 guests when it's at full capacity. And there we were. We looked like at breakfast, we looked like a very badly timed stag do, all in our matching t-shirt.
So this is the period when no one is supposed to be, you know, everyone else was staying apart from other people, but you formed a bubble. So you could work normally together, but you couldn't go anywhere else or touch anyone else, do anything.
We took a calculated risk, I guess. We knew that if we were going to be successful, we just had to hit as hard as we could early on. And as you hear, Ben actually became unwell with what we think was COVID. We were meticulous though in terms of the workspace. We were very careful we were keeping out of each other's way. If it came to food, we were keeping well distanced and all of that sort of thing. We had a brilliant cleaning regime for all of the touch points around the building. It was a big unknown then. It really was. It was scary. It was actually scary being there. You didn't know what was going to happen next. It was we were being told that within a few days there were going to be troops guarding the doors of the hospitals because they were going to be outnumbered, and it was a strange time.
It doesn't sound like a good environment necessarily for concentrating it, but how did it evolve? So you have this intense period, you're all living there for 8 weeks. What happened next? Presumably at some point you all went home. How did it evolve after that? It
seemed to go on for quite a long time, and it was being fed by pastries, fed pastries by Tom every morning, and working late into the evening because putting all the logistics together with it as well. Again, the teamwork was amazing, and I was lucky, fed pastries every day and just conducting this incredible team of engineers. It was my bit was fairly straightforward, I think, it did go on for weeks and weeks, and just as you there we go. That's trying to avoid the media. That's one of the trips in the hospital. One of the times. That's Mervyn with the moustache, and that's Andy Cowell with the glasses on, holding the Mark II version of the device. So there were regular trips down to the hospital. So there was a lot of testing that went on in between, just to make sure we got everything absolutely right. Because again, I've been asked quite a lot about the initiative and the hunch. Everything we did was really backed up with data, evidence. There was a lot of testing going on at Mercedes to make sure we were doing exactly the right thing.
And what was that? What's it like? So one of the things, I mean, I'm a physicist, and one of the advantages of being a physicist is that you don't ever have to deal with living things in a way. I don't have cell cultures that if I put them in a cupboard and leave them for the weekend, they'll die over the weekend. What was it like? So Tom and Tim, this is for the two of you. Maybe Tom done a bit of this before, but going from engineering something which is a machine, in the case of Tim, racing cars, basically you can leave a racing car for a month and it's totally fine. And frankly, if a racing car doesn't work, a lot of fans might be quite upset, but no one dies. Whereas in this case, that is literally not true. What's it like to shift, both of you, to this kind of project? Maybe Tim first.
I'll just say, and then Tom can take over. So we used to have a saying in motorsport. When the pressure was on, we'd sort of say, come on, we're not saving lives, but then we were in that environment. So what was our mindset at that point? It was very different. Tom, do you want to say something?
Yeah. So an interesting side of that was we were dealing with people at the end, as you say. We were making devices that would go and would help people who were very, very sick. And it came up in our design process. We had to kind of check ourselves. We had to go back to what we teach students, which is when you're designing something, think about the end user. So like this hood in particular, we did test that on ourselves early on. You might notice that lots of us are male, lots of us have short hair. Our original design was tested on people with a particular neck size, which was our group, and a particular hairstyle, which was our group. And then we had to look at that and go, that's not your average COVID patient. So we had to go down to the hospital and get a bunch of volunteers from hospital staff, some people with long hair, some people with short hair, some people with dreadlocks, some people with big necks, small necks, and put it on absolutely everyone. So it became a community effort, because you realize if you've got an end user who is a sick human, they come from across society. And if we're locked up in a little bubble of ourselves, the decisions we make that are good for us are not necessarily the best decisions for the very sick person at the end of this journey.
So I'd just like to remind the audience that if you have questions for our panelists, we do have time for some questions, not quite yet, but in a few minutes. So be thinking about your questions and do put them into the YouTube comment box under the chat, and someone will pick them up and pass them on. So let's first of all get to the project stage now. Who's going to take that? Becky, perhaps you can. What's going on now? When did it? Is it still going on? Did it? Actually, let's talk about the design and where the designs went. So, Becky, do you want to pick up on that?
Yes. So, I mean, so a big piece of what we ended up doing was actually international work, which, you know, we had in the back of our mind in the first phase of the project, where we were very focused on the NHS. But then there was, you know, basically this went out in the press. There was, you know, a lot of media around it, and we started getting absolutely inundated with approaches from other countries. And we decided very quickly that, you know, we'd done this to help people, and it didn't matter where in the world those people came from. So of course we had to keep going. So we took a kind of two-pronged approach. The first thing we did was to release all of the designs and manufacturing instructions through a zero-cost license, to make them available to other groups in other countries to manufacture locally. And we put a kind of whole support package around that. So training materials, clinical materials, regulatory support, a technical support team, supply chain support, working with the Department of International Trade and various embassies. And that's been really successful. So the license has been downloaded over 1,900 times across 105 countries. And, you know, there's been real progress in I'd say there's about 20 teams now, 20 countries.
And let's see the flags, because you did get them specially. So there's two in particular, right?
And I had to look up the flags. So these are lots of flags from different Latin American countries, actually. So we had a phenomenal collaboration with the Latin America part of the Department of International Trade. So Mexico, Peru, Paraguay, Uruguay, Colombia, Argentina have all progressed really well. They're manufacturing at scale. They've got local regulatory approvals. They're doing testing in hospitals. And, you know, to quote, for example, the Paraguay Ministry of Health. So that's been, you know, really phenomenally heartwarming and, you know, really quite emotional at times when you see these kind of reports back of these pieces of kit being made in other countries. They're using bits of kit that we've sent out to them, and they're getting treated, you know, they're being used on COVID patients. And then the other piece,
we've got two pictures, haven't we? Because there's two pictures
we have.
And the thing about these is that, in a way, these get to the heart of a project. So what we've been talking about is an exciting engineering project. You know, it's exhilarating, it's exhausting, it's all these things dramatic for all of you. But on the end of it, there is a person who can breathe. And it's such a fundamental thing, isn't it?
These are two examples of countries where we've supplied the devices directly. So obviously not all countries have the manufacturing capability to be able to respond quickly. But this is Uganda, Harona Hospital in Uganda, and then another hospital in India where essentially they're using these devices. So CPAPs that were made in Brixworth that have been shipped out through a charity that we've worked with, the International Medical Education Trust 2000, and are now being used in patients in these countries. So this is continuing. So, you know, to give a flavour of what's ongoing, I would say this probably still takes up several days of a week of my time in terms of working with all of these international partners, and there's still new ones coming on board all the time. So it's phenomenally rewarding, and, you know, I think we had a real obligation to do this.
So just to clarify for the audience, there was sort of two stages. There was the design and the prototyping. Then you made 10,000, and then the designs went out into the world, and they're kind of carrying on, because that's the nature of open source designs. It's just brilliant. So Ben, from the point of view of, after you got better, presumably you rejoined the team a bit. And how has this changed? You know, has Mercedes just gone back to doing what it did? Has being involved in all of this changed your perspective on how you can contribute? Was it just an interesting game, or has it changed how you do some things?
It certainly helped us realize some efficiencies in the manufacturing area. So we never really make anything on such a large quantity as we did with the CPAP. So you end up realizing sort of what all the little bottlenecks are and how we could really speed up the manufacturing process. So I think that we've definitely learned a bit about that. Trying to sort of equate that to how we actually speed up the manufacture of our F1 parts is something that we really do need to try and capitalize on, I think.
And you haven't had any engineers running off, Formula One engineers running off to be healthcare engineers yet, is that, or have you?
Not to my knowledge.
Okay, we've got a question from, I don't actually know who sent this in from the audience, but is there anything you would change now in the design and the process of designing the device? Obviously, hindsight is 2020. Could you, design and process, what would you have made better? Perhaps, Tim, this is one for you, Tim and Tom.
Yeah, we could make the device probably more efficient still and easier for the end user. The controls are quite delicate. That may be because we did one step of efficiency improvement, and in doing that, we may have made the device, the controls, a little bit more sensitive. So I think maybe we were lucky. I don't know. We made all the right calls all the way through. I don't think we really got anything badly wrong. But if we did it all again, I mean, I did start with all the suppliers. The first thing you want to do in an engineering project is make sure you've got the manufacturer and the supply of everything that you need, and that's where we started. I think as a country, as a government trying to control a crisis like this, and at a global level, there's an awful lot that people could do to be in a better place if anything like this happens again. It's been really quite shocking to see how badly prepared everybody was.
Brilliant, thank you. And we've just got one other question from Wiam Saeed, which is, how did you handle the time pressure? Who's going to take this? Maybe Ismail or Tom?
Tom, do you want to go
how
for
did
it?
we we didn't stop initially. We kept going, and we slept occasionally, and we had team meetings over meals. That was a great way that we were always just pushing for sort of the next 4 hours. You know, we'd meet together informally, share what we were each doing, and probably consume some food at the same time, hear what was working, hear what wasn't working, and then go back to it for another 4 hours. So we weren't fans of middle management. I think we had 2 formal team meetings in the entire project. Everything else was discussed over pastries, lunch, or dinner.
Feed your engineers. That's the message, Ismail.
Sure. No, I think it's just remembering what the end goal of this is, and you know that we're doing this to try and help people, and just keeping that in mind. Then your process of thinking about everything is in line, and you know you're doing it for a good cause.
Brilliant. So we are almost at the end of the time we've got, but I have a question for each of you, which is, what was the best moment? So, you know, and always there's the sort of obvious ones, right? But sometimes it's the unexpected things that catch you along the way. So best moment, who's going to go first? Ben, you can go first.
Yeah, you did a bit. Blimey. I think it was explaining the story to my family afterwards. I think sort of a phone call from London in the hotel room, trying to describe it. And one of my nieces is a doctor, and so she was telling me some stories from the hospital about how resources were so sparse that she was told not to treat some of the elderly people because they had to make a choice, and it was incredibly sort of poignant, and on the backdrop of how hard we'd been working. I didn't actually manage to hold my stuff together, I have to admit, when I heard that story, and that's very unlike me. So yeah,
brilliant.
That was probably the most poignant moment.
Thank you. Ismail, what was your best moment for you?
I think it was probably the moment we realised that the perfect name for the device was on that T-shirt that Tim's wearing, the Ventura. So I think, yeah, no, that for me was a bit of a comedy moment, but a bit of stroke of luck, I think.
I'd always wondered where it came from, and of course I assume there must be some great deep and meaningful philosophical background. I quite like it's just come from a T-shirt. Best moment, Tom?
The serious one was seeing it on BBC News, but the hilarious one was trying to convince someone on the phone that I wanted to actually buy 20 kilometers of oxygen hose. They thought it was a wind-up initially, but we did need 20,000 meters of oxygen hose for this project.
And they did sell it to you?
Eventually.
Okay, best moment, Tim?
Just the teamwork, amazing. You know, nobody paused. It was unbelievable. Everybody came together, and we just carried on and carried on. And also, I mean, echoing what Ben said, you know, we were engineers. We get so focused on the engineering and what we're doing. So when it did suddenly appear on the TV or something like that, it really did stop you in your tracks and actually make you realise, wow, you know, we're doing this. That's us. And that was incredible. And also just support of family and friends. They know that we do get a bit selfish sometimes with the projects we do as engineers, but you know, they no questions asked. They just let us get on with it.
Brilliant. And Becky, how about you?
It's really hard to pick one point. I think for me, again, it was really the people pieces, but it was lots of them. So, you know, I remember the day where we were sat in UCH on a Sunday afternoon. My youngest son had cut his head open that morning, so it had been a particularly bad day because I'd already been to UCH once that morning, but we were back there that afternoon, and it was the first time one of them went on a patient, and Tim and I were sat there in the kind of critical care kind of common room. Obviously we couldn't go on the COVID ward. Dave Brearley went in there and put the first one on a patient, and we just sat there waiting to see how it went, and he came back and, you know, all was well. So it was a whole series of moments like that. You know, every evening Mervyn would ring me on his way back from his shift. So it was about 9:30 in the evening, and he would ring me every evening on driving home in his car, and we'd debrief on the day and work out what else we needed to do that day. So we still had plenty to do, but, you know, he'd given me an update on how it was going at the hospital. We'd talk about who was using them where. So it was the human stories, and the kind of, in many ways, it was very kind of emotional, because as engineers, we're not kind of trained or used to being on that end of the kind of delivery. But it was, you know, such a privilege and so incredibly motivating to make it happen that I think it kept us all going, and still does. You know, we're still going, and we will continue to still going, and the international work's a really good example of that.
Brilliant. Well, that is a great place to finish. We are out of time, which is a shame because we could clearly talk about this for a long time. So you're all obviously superstars, you and the rest of the team that made this happen. UCL is obviously very proud of you, and we're at MechEng are very proud of you. To all the audience, thank you for joining us. I hope you've learned a little bit more about what goes on in the insides of engineering departments now. If you are staff, students or alumni of mechanical engineering, there is an informal discussion about to follow on Zoom that you already have a link for in the email. So please join us on Zoom in just a few minutes' time. To everyone who's joined us today, thank you so much. Keep an eye on MechEng. Interesting things happen here, and that's all from us. Thank you very much.